What is this T? Time period of revolution of particle revolving in a circular path. Is it okay? Let me put all the things. What is capital T? Time period of revolution of particle revolving in a circular path. Also, what is the time period? What is capital T? Also, time taken by its projection to complete one to and from motion. Time taken by projection of particle one to and fro motion. Is it okay? I think both are same. No? By the time the particle completes one revolution, what happened to this particle, its projection will complete one to and fro motion. I'll call this as time period. So time period of to and fro motion. And again, the particle after completion one revolution, again it go for second revolution. Again, what happened to the projection? It will also complete second revolution. So like that, what happened? As long as this particle is moving in circular path, what happened to this projection? It will be executing SHM. How long? As long as this is moving in circular path. So shall I say that this is like a periodic motion? I'm not bothered this one, particle one. Now I'm bothered about the projection. Look at the projection. Is it a periodic motion? What do you mean by periodic? I do have one more example. What do you mean by periodic? Shall I call this a periodic function? You know function chapter, completed functions, mathematics. Anybody reply back?
Sir. Yes.
Yes, sir.
No. Okay, then periodicity you call. Am I right? What do you mean by periodicity? A part of graph which will repeat again and again. So this part of the graph is what going to repeat. No, again you get sine. Again the same part will be repeated. So this is a periodic function. And what is the time period? The time period is this one. This part of the graph is what? Repeating again and again. I'll shade it for your convenient. This is called like a, you call positive off cycle. This is a negative off cycle. This part of the graph only what happen is going to repeat again and again. Again, you'll get positive, negative. Again, you'll get positive, negative. This is called like a periodicity. Here in or physics, we just call time period. So the same thing here also. This is one period. This much is you have to call this as one period, or distance between one thrust and graph. That one. So that like that's also in physics you can define. And what happened to this particular now? You look at this spring block. It will continue, finish over. It will continue like that to and from motion. Sir, I want to know how its displacement, how its x varies with the time. Can we write equation? The same equations. Same equation. So, sir, can you write equations for motion of the spring block? Yes, we are in a far best position. X a sine omega t. What about the speed of this? A omega cos omega. What about acceleration? Minus a omega square sine omega t. Are you getting? So slowly I'm dragging you to some other concepts using this particular thing. Okay, look at this one. So now we are in a better position. What is the speed of the block after certain time? Put that time t here. Look at the speed after certain time. Where it will be? It will be at a certain distance. So this x from where you're measuring from here. So this is what x equal to 0. Am I right? What do you mean by x equal to 0? Mean position. So the to and from motion who is describing this block only. Now you see that one. Did I ask anything in workbench chapter? What the time taken by the block to move from here to here? No. At that time we don't have any idea of this one. Now what happened? We are in better position. On one side we know conservation of mechanical energy. Other side we know trigonometry. Yes, I'll combine both. Now I can ask you anything about the spring block system. What is the speed of the block after certain time, or what is the speed of the block after certain position? So even you can take help of this formula. Agree this? So with the help of this, we can get all the things what we needed here. So this is, so shall we call this as t equal to 0? This as t equal to t by 4. Just wait. Meanwhile, you look at this one. Okay, no. So this is about the, we know x equal to 0 means from where you are measuring x equal to 0 from mean portion. So what is x equal to a? This one x equal to a. This one is x equal to, this is x equal to minus c. So now the time period t equal to t by 4. So what about the next one? T equal to t by 2. What is this time? T equal to, this will be 3t by 4. I'll write it here. And again, this is t equal to capital T. I'll write it here. This is the left extreme. Okay, I'll shade it so that it'll be, you can notice it. Huh? Okay, agree this one. So it's like a to and fro motion. This is what happens in to and fro motion continuously. Okay, now let's do one thing. This time period depends on what all. Just make observation. I want everyone to make observation. Please do make observation. Time period depends on what all parameters. You have everything in front of you. Time period depends on what all parameters. Anybody? Somewhere you have equation? Anybody, please, you have to reply.
Mass and spring constant.
Mass of the block and spring constant. Is it, will it depends on what speed I'll give at mean portion? Anybody wants to answer? So I'll give more speed, 10 meter. I'll double the speed. Okay, amplitude will increase. So how do you can say? Okay, let's go back to the workbench chapter. We know many things. Huh? I'll give velocity to the block here. What all kinetic energy I give, that'll be available as elastic potential energy stored in the spring. So shall I write few things? Half m Vm square. Okay, already I wrote it. This should be equal to kx square plus mv square. I can also write okay, look at this amplitude. Amplitude depends upon what? Okay, now we know Vm is equal to, according to the formula, Vm equal to a omega, put x equal to 0. So therefore this amplitude, either solve this or any of the equation you take help of this one. So this amplitude depends upon what? These things. Okay, now you try to look at this one. This omega depends on k and m. What is k? Spin constant, not kinetic energy. The time period depends upon mass and spring constant, mass of the block and spring constant. The amplitude, what happens, depends upon what speed we are going to give as the mean portion. So means either you give amplitude, if you give this displacement, like if you give Vm or 2Vm, 3Vm, amplitude will change. But what meant to time taken to complete one oscillation will remain as it is. So therefore, shall we put one more thing? The time period is independent of amplitude of oscillation. The time period is independent of amplitude of oscillation. The time period is independent of amplitude of oscillation. Will you agree this one? Means we can also, I can also give justification like this. Huh? So all of you got what do you mean by time period? Time taken to complete one to and from motion is called as a time period. Okay, just one more very important. Okay, now a student, what happened? He will take a spring. It is there at mean position. Okay, no, not that mean. He will pull that to right extreme like this. Okay, fine. So here he will give amplitude. He will pull that spring and he will release from rest. Releases from rest. Okay, now you will release. It will describe to and from motion. If another student, what happen, instead of pulling this by A, if you pull this by 2A and release. So this block, what happen, will come to here. Okay, there's a one block. I'll give a yellow color. And this is very important discussion which I'm making. Now another student, what you'll do is like he will pull this by block by distance how much? 2A. T equals 0, let me release. I can release here, releases from rest. No, by the time it comes here, it will have some velocity. I am not bothered. Okay, what is some velocity it will have, and spring constant kx1. Okay, you write kx1 v1. Okay, let me write v2 kx2. By the time block comes here, it will have maximum velocity. Okay, this is vm1. This vm2. Okay, same spring. Spring constant is same. There's another block. Only thing is the amplitude is given different. So what do you mean by amplitude? How much you pull the spring? Okay, now tell me like at t equals 0, I release both, no? Actually, I to just already I discussed the amplitude is independent, time period is independent of amplitude of oscillation. I'm just trying to give some explanation. What is the time it will take to reach to from extreme to this one? Because the release from rest, this will be like a right extreme. This will be mean. This will be right extreme. This is a mean. Will both blocks will take same time to reach mean position? Anybody give answer? Can you give answer? Or
Yes,
will
sir.
it take different time? Both will take same time, t by 4. And what is t? Finish sure. So what you can conclude now? Time period is independent of amplitude of oscillation. Time period is independent of oscillation. Either you, instead of giving velocity, I'll pull this now, I'll release from rest. I think you know enough this one. I'll just hold the spring, I'll pull it like rubber band. How you stretch it? There's like a rubber band. You connect one stone and leave it, and it's going to execute to and from motion. I'm just showing only 1/4 of oscillation. I'm just showing only 1/4 of oscillation. So with this, what you can conclude, time period is independent of amplitude of oscillation. How much we give amplitude, that will not determine time period. That's the one conclusion. Next, again afterwards, what will happen to overall energy what we give? Here I give energy in the what form? The kinetic energy. Here in energy in what form I'm giving? Potential energy. Exchange agent will do work, no? So what all work done by exchange agent will be available as oscillation energy. What will happen to that oscillation energy? Will remain same. So shall I say SHM is a motion which will obey law of conservation of energy principle, law of mechanical energy, also which will obey law of conservation of mechanical energy, because overall mechanical energy remains same. So shall I say that in synchronic motion, what happen? The body will describe the motion in such a way that mechanical energy will be conserved. The body will describe a motion such that its mechanical energy will be conserved. So there's one more conclusions is what we are going to make it. I'll show it this description also. So what is the conclusion? We'll make it in SHM. In SHM, mechanical energy of system is conserved. Okay, there's a one thing. Next, after this, next one more point. What we say that one, amplitude time period is independent of amplitude oscillation. So now first question, is it SHM periodic motion? Yes. Is it oscillatory? Yes, it is. So like that will happen. So we can classify now the types of motion here. Okay, this is about the theoretical idea. What we'll stop it here. I'll go for paper discussion. Fine. Okay, we'll discuss the paper. Tomorrow I'll continue from here. So that spring block systems is what all our numericals, to be frank, that one. So you do get two types of problems where numericals will be there, like this mass oriented and spring block problems oriented. Okay, we'll start the paper.